something too loud, let me know. I try to.
Yes, speak up, because it's hard to hear.
Okay, so I will tell you about a little project that we're trying to set up. We're interested basically in the lab. What we do is basically study societies of cells of every kind, and I'll talk about a little bit of what we can do with bacteria and basically try to take it to transform certain mini ecosystem, which is some sort of a gadget that's already out there, into some sort of a sensor that could be used by kids to basically solve an issue, which is this separation between us and nature, which I think somebody touched it with this project, the succession with the old trees, because I think a lot of the issues are related to that. So I will introduce you very quickly to this device. It's called the MATBOT, which is basically a bacterial fuel cell, which touches things into sustainable energy, which is basically something very simple. It's a compartment when you fill with dirt, of earth. Basically, every sample of dirt has bacteria that are coming with it. Basically, when you put it, the guys that like oxygen move to the top. They basically deplete all the oxygen, creates an exponential decay. Therefore, at the bottom, there is no oxygen in this anoxic environment of the type of bacteria that's always in soil. Deplete basically does anaerobic respiration. So therefore, instead of passing an electron to oxygen, it will pass it to anything. So if you put a cathode an anode at the bottom, it will pass it to it, and therefore it will generate an electric current that you can use to power electronics at the top, usually open source electronics, whatever you want. And therefore, the idea will be to transform these guys. By the way, the guys that live at the bottom form these very interesting biofilms that form all kinds of connections with nanowires and stuff. There is the scale if you guys are interested. And basically the thing, you can make it on a drawer, you can make it on a bag, whatever you like. The idea will be to use Chile as a laboratory. Chile has a very nice advantage. I'm from there. By the way, you're all invited to come. It's really at the end of the world, though. But by the way, what you have there is a very perfect one-dimensional transect in which you can have locations all the way from Atacama all the way to Antarctica. We have towns in Antarctica. And basically, the idea will be to sample all of those things. And basically, also Chile has a lot of diversity, not only in weather, but also in urban settlements. You have cities of 7 million people, like the capital in the middle, to very tiny cities like the ones we have in Antarctica with only 50 people. And also, there's a lot of inequality in Chile, and there's also a lot of differences in the level of detachment to nature. If you go to small towns, like in Antarctica, you have a really deep connection to nature, to soil, etc., in comparison with people that live up there in the city with basically the only connection is to Facebook and Twitter. And in this sense, the idea will be to use basically the public school system in Chile to basically transform kids into a sensing device, which what we could do will be to use them to generate basically a map using basically the typical things, apps, and then generating meshes with Sibeli or all kinds of things like that, in which kids themselves in classrooms can basically measure the electrogenic properties of Chilean soil. And you can have basically the properties of the soil in the north and all the way to the soil of Antarctica, and use the kids themselves, the public education system, which by the way is undergoing a total revolution, because in capitalism in Chile, education became a good of consumption, and now we are changing it to be a right for the children, right? So basically the idea will be to use this device as a sensor, use the place as a lab, which was a gift that is this gradient, and basically turn kids into scientists and learn electronics, learn about open source electronics, learn about biology, learn about biochemistry, learn about ecosystems, and basically also integrate themselves because they are very separate. Thank you very much.